Today you're going to be doing some more practice with relative dating. I'm going to give you a few more difficult examples for you to tackle. So this video is going to go through two examples for you to help you understand the process of relative dating. To start off, I want to go through another animation to show you something called geologic sequencing. This puts certain geologic events in order from oldest to youngest, or which formed first and then which one formed more recently. So before I start this animation, I want you to note that we already have 4 different horizontal rock layers that have already been formed. The oldest rock layer is on the bottom. The youngest rock layer is on the top. That was the one that was formed most recently. Remember that as rock layers are deposited, they're originally deposited underneath the water, and they form from oldest on the bottom to youngest on the top, and they're initially in horizontal layers. There are other processes that can act on these rock layers that this video is going to show you. So if you remember from last lesson, there's a process called folding where mountains form and these rock layers get curved or folded. Weathering and erosion can then take those rock layers away. Over time, as sea level starts to rise again, new rock layers can be deposited, which you can see in those brown rock layers there. Now this video went rather quick. I want to go through this one more time with you. So remember, we're all starting with horizontal layers. The process of folding lifts these rock layers up, exposes them to the environment, and weathering erosion takes some of these rock layers away. As sea level rises, new rock layers can deposit and form, and you'll see that those gray layers on the bottom that were folded, those are no longer horizontal. The new rock layers that have formed on top of them are horizontal layers. So the bottom gray layers show that evidence of folding, while those top brown layers don't have any folding that happened yet, so those rock layers are still horizontal. So I'm going to go through an example diagram with you. In this diagram, we have different rock layers with letters A through G. So we're going to start with the oldest and then work our way up to the youngest. So if we remember the law of superposition, the oldest rock layers are generally on the bottom of the rock layers. So we're going to start with rock layer G. The deposition of rock unit G formed first. Then on top of that, we have the deposition of rock unit F. On top of that, next was rock unit E, followed by rock unit D. But we have to be careful with this one because if you look at the symbols, rock unit D and H share the same symbol. So those rock units are actually formed at the same time. They don't look connected for something that we'll talk about in a moment, but rock units D and H were deposited next, then followed by rock unit C. So now we have to take a pause because if we look at the rock units that are on the bottom, the ones that I have highlighted in blue right now, you can see that all those rock layers are folded. They're no longer horizontal. While the rock layers on the top of that, rock units A and B, are perfectly horizontal. So something must have happened here to cause this change in the pattern of the rock layers. Since all of the rock layers on the bottom have that folded appearance, we know that what happened after the deposition of rock unit C is that all of those layers were folded and then uplifted into the environment. When you have that uplift, all of those rock layers get pushed really high in the atmosphere, and that causes weathering and erosion to happen. If we look at rock units D, H, and C, you can see that they are broken up. They're not whole rock layers anymore because weathering and erosion broke down those rocks and transported them away. The next thing that we need to understand is this little bit more of a challenge type of scenario, so I'm not going to really expect you guys to talk about this too much, but I want to give you the whole story. Next is something called subsidence. Sea level rose again, and all those rock layers were covered in water, which caused more deposition of new layers. So then after that, we had the deposition of rock unit B, followed by the deposition of rock unit A. But we're not done with the story yet, because if you look at rock unit A, you can also see that some of the rocks are missing. It's not a complete layer, and again, that's because weathering and erosion took over and removed some of those rock layers due to breaking down the rocks and transporting them away. I want to show you one more example. This one involves an earthquake where we have fault line XY. So if we're going to start with sequencing these from oldest to most recent, I'm going to start looking at the bottom because of the law of superposition. So if we look at rock unit A, the deposition of that rock unit formed first, that's the oldest. Now before we move on, I need to highlight for you guys this fault line that represents an earthquake. If we look at the fault line XY, it cuts through both rock units B and C. It does not cut through rock unit A, and it does not cut through rock unit D, but it does impact and cut through rock units B and C. An earthquake can't break through rocks that didn't already exist. So we need to forget about the earthquake for now. And before the earthquake happened, we had the deposition of rock unit B. But if you notice, rock unit B has been split up because of that earthquake. You can see that the symbol for rock layer B is also found on the other side of the fault line. So please remember that those two match up, and the earthquake is what broke them up. So we had the deposition of rock unit B next, and then we have the deposition of rock unit C. Now that those two rock layers have been formed, then the earthquake happened because those rocks needed to be there first before the earthquake could impact them. So here we have the earthquake, which is shown by fault line XY. And then the last thing that happened is the deposition of rock unit D. Rock unit D had to happen after that earthquake because if rock unit D existed at the time the earthquake happened, rock unit D would also have been impacted. But since it was not impacted, it must not have formed yet, so rock unit D formed last. It's the most recently formed, the youngest rock layer.